in my 9-to-5 life, I am a assistant professor at Delft University of Technology, and I am not a developer, nor a computer scientist. I usually do sensor design in the world of water management and hydrology. So yeah, so I'm really excited to be here standing for you. But that is maybe not, some of the Dutch people might recognize some of my work, because what I usually do is I talk a lot about how technology is accessible to everyone. And I am what I like to call, here, we just needed a broom to make something work last minute. I am what I like to call a tinkerer. And I want to talk about tinkering today, and I know that you work in making beautiful applications in the medical world, which is not necessarily a world where tinkering is appreciated a lot. Bear with me. I do have to sometimes explain what tinkering is, and I got two really simple examples from one of my books that I wrote. And this is the first example. When I started to write this book, I wrote it at home, and I was sitting at my kitchen table because I don't have a office at home. And what I wanted was one of these fancy standing desks, really hip, so you can like stand and type. Supposedly, it was the second book I wrote. The first book I wrote was my PhD thesis, and I wrote it at the same kitchen table. And I can tell you, in Dutch, kitchen tables are not Arbo-proof. Having spent 3 months at a kitchen table, your back is gone. So I wanted to have one of the fancy standing desks, so I went to IKEA. Apparently at IKEA, standing desks are 700 euros. Yes, and I was going to buy one to write a book on how you can do technology on the cheap at home. So the moment I saw that, I realized I can't do this. I just have to spend a chapter on making a standing desk for less than 100 euros based on stuff you can buy at IKEA. And that's really simple to do. What you do is you go to the department where they have the ironing boards. You get 2 ironing boards, you remove the cloth part, and then you get 2 of these boards that you use for, usually for books, but most people use them now for the cheap little trinkets you buy at the Action. So you got 2 of those boards, you bolt them down on the ironing boards, and then you get 2 hinges to connect it all together. And that's really convenient because then you can just fold in the ironing boards and stack it between, as you can see over there. It just fits between my heating and my cupboard there. And when I want to work, I get it out and I crank it up and I put it on my table. Works perfectly, 80 euros. It has one drawback. If you put an ironing board on this height, it kind of behaves like an American car in suspension sense. So which is okay for typing because it's kind of relaxed. But I was making a book about making, so I also had to do a lot of soldering. Trust me, that's dangerous. Oh, and there's one thing, I said, get everything at IKEA. I didn't get the hinges at IKEA, I got them at a DIY store. Later I learned you can also get separate hinges at IKEA. You just go to customer service and you say, I bought a Hemnes, no hinges. And it's cheaper for them to just send you away with a bunch of hinges than, are you recording that? You didn't hear this from me. But that, in my opinion, this is tinkering. And it's useful, because now I have one of these things, and it's not pretty. My wife continuously says it has to go out of the living room if people visit us. Not all tinkering needs to be functional. Sometimes it's just fun to do. It can lead to very important things, but sometimes you just tinker for fun. And that's my second example. Has anyone seen The Art of the Brick? Hands up. 1, 2, 3. I'll need 4. People are slowly acknowledging that they still love Legos. For those who didn't put their hands up, it was a exhibition by an American artist, and what he thought was art was recreating existing art using Lego. It's basically it. Just the Mona Lisa in Lego. And I was discussing this with Feline Hermans. Feline is a developer. If any of you is involved in the Joy of Coding movement in the Netherlands, she's an assistant professor in our computer science department. I was discussing this with her, and we agreed that's not art. It would have been art if the Lego had made the copy of the art itself. Yeah. Feline is also, it won't surprise you maybe, an international judge in First Lego League, the competition where kids make robots using the Lego Mindstorm series. So we set to work and we created an art copying Lego machine. Basically it's a car that can drive in that one direction, and on top of it is a car that can drive perpendicular to it. You can see it here as well, so it drives in this direction, the small car goes in the other direction. On the smaller car is a sensor that can sense 1 pixel worth of color. And that scans the little image. And then there's a little grappling arm claw thing, and that picks up little Lego bricks in the appropriate color and places them over there so we can recreate art using Lego. It's not artificial intelligence yet, but we're getting there. And I have to say, I mean, Feline is kick-ass in software and in Legos. My main contribution was when we finished this, 2 30-plus-year-olds laying on the floor playing with Legos an entire Saturday. When we had finished this, the claw didn't grip the bricks too well, so I had to add my contribution, 2 rubber bands that make sure, I'll walk here as well, 2 small rubber bands that make sure there's enough grip. 1 evening worth of tinkering. And I think that's important. And I like tinkering, and sometimes I just try recreating stuff I've seen. Has any of you seen Dirt Gently? Hands up. Okay, a few. So you may recognize this one, because I saw Dirk picking, sorry. Sometimes he is a jerk. I saw him picking up that lamp that just goes on when he picks it up, and then goes off again when he puts it down. And that goes on again when he picks it up. And I thought, I've been on television a few times, they're tricking that. There's someone with a remote control doing stuff. But I also thought, they don't need to. I think I can make that. And if not, I'll take my ring off. It's not my ring making contact or something. It's just the way it was. Basically, what I did, you can buy these lamps that have these cords that turn them on and off. They're super convenient for like in storage spaces or in tents or whatnot. They're like €7. And I opened them up and I added a small capacitive touch sensor in it. And basically what it is, it's a SparkFun, it's an Adafruit sensor. It acts as a switch based on capacitive touch. It's a 1 pixel touchscreen. That's all it is. So that now switches the lamp. But then I did want to understand how that worked. Because, I have a background in physics, so I thought, I can use it, but I need to know how it works. So I looked at what was on that little board that Adafruit sold me. There was a little chip on it made by Atmel. So I looked up the data sheet. And I started reading this data sheet. And I thought, that's interesting. This is how I use it. This is all the limit cases. I read it. I read it, and I read it, and I read it, and I read all of this. Trust me. Turtles all the way down. Now seriously, when you start reading that, at some point, you find that, okay, apparently they're using a layer of touch-sensitive, capacitive material, and so I had to look up Maxwell's equation again, about how electromagnetic fields are affected by changes in the material around it. And then to understand Maxwell's equation again, I had to go back to my quantum mechanics courses. And at some point, I just found articles that said, we don't know. Yeah. And on the one hand, that's a bummer. On the other hand, I did manage to get that thing working. So how important is it? And that stuck with me. That stuck with me for a long while. And what I want to talk about today is how I learned not to care about that. And for that, I'll have two more examples and a demo. The first example is from my day job. Measuring water from Delft University. This is the confluence of the Irrawaddy River coming from the left and the Chindwin coming from below. One of the nicest things about these two rivers is that they come in each other at a 90-degree angle. This point is at a different place every year. This is in the low season. And what is also a really nice, someone's got a phone. What's also a really nice thing is that the Chindwin, as you can see, has a lot more sediment in it. You think, yeah, is that important? No. Well, it is important, but it's mainly important that we want to know how long it takes before these two rivers completely mix. That's important if one of them has a pollution, a factory blows up somewhere upstream, to know how far downstream we have effects and how that all plays out. We were there to measure the mixing at this confluence, and we were very lucky to have a cameraman with a drone with us, because then you can get this kind of pictures. The way we measured that mixing is with drifters. Drifters whose location we can track. We got two types of drifters, coconuts with balloons, that's the one type. They're really good because you can get a lot of them for low money. And then this is the second type of drifter. It's made from basically styrofoam that we found lying around. But the important part for my research is the little box up there that has a device in it that has a GPS receiver and a GSM sender. It logs its location every minute, every 15 minutes. It calls into a server, and then on that server, it's a server. I don't know if anyone knows this device. It's a particle electron. It's based on an Arduino, but it isn't one. On that server, you can send the data forward to different services. You all do APIs. You get it. So it's sent to a server, I can put a webhook on there, and then I can forward to whatever I want. When we were doing that, I really wanted to be able to track them in real time. I mean, you're releasing them in a river, they're going down, you lose track of them. So what I wanted was to look at my phone on a map and see where they were. And for that, I needed to build something, and I did it on my own website, that basically has a map and plots the incoming data. And I have to say, I did that. And this is, I mean, from a programming point of view, nobody could sell this. I get that. I mean, Google Maps looks better and whatever. I was so proud of this. I still am. And I'll show you where it's at. It's this one. Yeah, so I can, your screen is to the right of mine. There you are. See? So this is just on my website. Please don't copy the URL. I don't have that much traffic, etc. And now I can, somewhere in the top here, I can select which one I want to track. I think I was tracking number 11 the other day. Yes, no. There's one, I think it's number 9. Oh, churning data. There we are. So that was the one you just saw. And then I can like click on a point, and I can see at what time and what exact location. I was so happy with that. That made me, so I am trained as a physicist in cochlear membrane modeling. I'm now doing sensor design for water management. I do nothing with web design. I made this. I was so proud of myself. There's one that I accidentally put on when we got back from our campaign. I accidentally put it on again. And this only shows like the last measurements you do. So if you want to know, I work in Delft and I live in Haarlem. Let's get back to my slides. So yeah, still proud when I think of that. I made that website demo. This is, by the way, how I kind of did that. A message comes from the electron, goes to the particle cloud. Then a webhook translates that into something in JSON. I had never heard of JSON before. Sorry. And then that gets posted to a PHP on my site, where I put it in a raw data repository, but I also process it, and then I have a real-time map. That's what you just saw. That gets the data again. And yeah, that looks like this. And I think the most important thing on this page for today, I may have to kick over some DevDay letters, is here in the bottom. You can see it over there. Copyright leaflet. Because I didn't make these maps. I just used the leaflet API to get base maps, and then use the API to add markers to it. And for you, this all makes sense. This is all natural. For me, it didn't. It was the first time I ever did that. So I had to look up the leaflet API reference. I found, luckily, the GeoJSON, how you do that with a good example. But I didn't understand it. I didn't understand how they did that. It worked at some point, slightly, but again, physicist, I want to know how the world works. I wanted to dig deeper. I wanted to know, okay, but where did you get your maps from? How do I know that your maps are correct? So I dug deeper and I found there, because it's all open source, I found their leaflet, source, core, class, JavaScript, somewhere on GitHub. And then they said, okay, then we import maps from another service, and then so again, there was all the way down. I couldn't find how the map was drawn on my screen, but it did work. Also, I said I started out looking at the API reference. I didn't finish there. I got it working on Stack Overflow. I think this is a common thing now. I've learned that. I'm probably not the only one. But I realized I can get maps on my screen, and if we go back to the actual map, the reason why I started asking myself, where it is, look, I knew for sure that my drifters were in the river. And OpenStreetMaps didn't know. I just found out, apparently, that river changes its course because of all that sediment load every year. And those maps are a few years old. But it takes you some digging to find that out. And that brings me to my final example, which kind of is, I think, my 15 minutes of fame. I was allowed to talk on Dutch national news, like some kind of weatherman. Some of you might recognize the area. I was allowed to talk about something that happened in the San Francisco Bay Area. And I have a movie about what happened. How's my sound? My sound is good.
Documentaires die je niet mag missen. In Alcatraz de ontsnapping verklaard onderzoeken 3 Nederlandse wetenschappers.
Als het zo kalm is als dit, dan komt het allemaal goed.
De beroemdste gevangenisuitbraak uit de geschiedenis.
This is the story and the research waiting to happen.
The tide is taking all the water out.
They
have one shot at it. And that's gotta work.
Alcatraz, de ontsnapping verklaard. Zondag 27 maart bij Discovery.
Ja, So, for some reason, I was allowed to paddle away to freedom in a little boat made out of raincoats from the prison island Alcatraz. Yes, I wasn't the first one. That was because we did some research with 3 scientists. The research we did is we took a model of the bay, the San Francisco Bay Area, and we modeled how the water flows in and out with high and low tide. And then we added some particles, some drifters, virtual particles to that to see what would happen in the event of the 1962 escape from Alcatraz, the one that was being made into a movie. We would see where the particles end up. And so we could tell what the chances were that those 3 men that escaped actually made it to shore. They've never been found. Neither dead or alive. And I say 3 men, and I think that's important. I didn't do that alone. These are also the 3 that were allowed to do that escape, but that's because we did research together. Dr. Olivier Roes is a colleague at Delft University. He's an expert in modeling water flows in estuaria and polar systems. So he had that model. Dr. Fedor Baert is an expert in visualization and in calculating where drifters end up. When that Malaysian Airlines flight fell into the Indian Ocean, Fedor was asked to backtrack where it could have fell in the ocean versus where some of the debris was found. And then you may ask, well, you said you had a model, you had particles and a visualization. What did you do? And that's a good question. Because my basic role in this research is that I did this yesterday, I'm really good in sitting on the couch, watching TV. When I was a student, I did that a lot. And what I saw, really important to my career, aim tegelijk, Mythbusters. Seriously, Jamie and Adam showed me that you can make anything. But more importantly, in the first season of Mythbusters, I saw them escape in their little raft. So when I, 15 years later, walked into the office of Olivier Roes, really, I'm not lying about this, for a roll of duct tape. He said, here, look at my screen. I just modeled what the San Francisco Bay is going to do in 50 years with climate change. Okay, cool. So he showed me that he had calculated what the effect would be of 0 to 5, 10, 50, 100 centimeters of mean sea level rise on the ebb and the flow of ebb and tide, the flow of the tides in the bay. Would high tide mean with 1 additional meter of sea level rise that half of San Francisco is underwater? And this is not something where you take the current level and just add a meter. Highly nonlinear processes going on, so you need to really model it. So he showed me that, and all I could see was the island in the middle with the vectors going back and forth. So I said, if you can model this, if I give you historic data, can you model 62? He said, yeah, but that's historic, it's not important. He said, no, let's do this. So we did that, and then we asked Fedor to do the particle tracking. We presented it at a little conference in San Francisco, where we were anyway, and then suddenly the BBC showed up. And once the BBC showed up, suddenly all these people showed up. And then your story is all over the news, and then someone that does documentaries calls you and says, look, we want to have you in this documentary, your research. And we were like, oh, well, that's fun. I've had that one time before. So I thought, okay, we're going to have 2 Skype conversations, and then afterwards, they'll hire someone that looks pretty that can then tell about it. And then in the second Skype conversation, they said, yeah, and then you'll have to calculate when the tides are exactly the same as then, so then you can actually escape. And we were like, what? And 6 months later, we were in the water. And I can tell you, it's Olivier's job, paddling. Fedor is the longest of us. The boat was made of raincoats. Even the floor was made of raincoats. Historically accurate. So Fedor's job was support. Structural support. He just sat in the back and made sure it stayed afloat. And it was, so the pontoons we made to stay afloat leaked like a sieve. So my job, I had 2 surgical tubes. Like 90 minutes long. I can tell you I had muscle cramps at places I didn't know I had muscles. If you want to know if we made it, look it up. You can find it online. It's freely available at PBS. You probably need to set up a proxy server or a VPN, but if you don't know how to do that, you shouldn't be here. Are there people from marketing here as well? Sorry, very easy. Most people from marketing also should know how to set up a VPN. So, but what I find is important in this part is that we could do this research because I can talk to Olivier about his research. He can show me his research, and he is the world expert on modeling these flows in estuaria and polar systems, as I said. I couldn't do that. I couldn't even begin to understand where he starts. But what I can do is talk with him about it. And I can talk about it in common language. I know that if he talks about a bres in Dutch, then he means a levee failure. And because I can talk with him, we can come up with ideas. I can see how his work links to mine, and we can work together. And he can give his results to me, and I can build on that. And he can give his results to Fedor, without Fedor knowing the exact details of how the model flow was modeled. And Fedor can do his particle tracking based on that. And we wouldn't know the intricate details of the Python code Fedor uses for that. But still we can talk with each other. And being able to talk with each other, I call the T-shaped model. Does anyone recognize the T-shaped model in this form? Hands up? Yeah, one, because it is from a software company. Valve uses this. The game devs. This is the T-shaped model for their heavy in Team Fortress 2. And the heavy is really good in heavy weaponry. Makes sense. But the heavy is also broad. Not only physically, but as a T. Because he is also good in sandwich preparation and Russian folk dancing. Not a world expert as he is in heavy weaponry. But still, good enough to have a conversation with someone that is an expert in Russian folk dancing. And they can come up with new ideas, new things to make that combine heavy weaponry and Russian folk dancing. And I, for one, would really like to see that. But this is also how my world works. I think by now I can say, based on the work I do, that I'm kind of okay with sensors and tinkering. And Olivier is really okay with modeling water flows in polar systems. So if he needs a sensor solution, then I do need to know that if he talks about quell, I think the English word is seepage, but that has so many more meanings than quell. Quell basically means if you live below sea level, there's negative pressure in groundwater, so it comes up. That's quell. It's also seepage. But if he talks about that and wants to measure it, I have to know what that is. I don't have to intricately know all the processes involved. And I think that is really important. And actually, when you start thinking about that, isn't that what an API is? And we're here talking about fire for 3 days. Isn't that being able to talk to each other, being T-shaped, what an API is? I had to learn, and the Alcatraz research learned me that, to let go that I won't understand Olivier's expertise. And I can still work with him. I had to learn that I won't understand how Overleaf draws a map on my website. But I can still use it because I can talk to it. So it's important to learn how to talk to people. And I think we have to extend the idea of an API beyond programming. We're talking about APIs here for 3 days as a means to communicate between devices, servers and clients, devices and servers. But isn't it ultimately just a way to communicate between developers? One developer has made something on the one server, one developer has made something on the other server, and you're talking to each other without having to look at each other's code. And you're trusting each other. I trust Olivier to do his calculations right. He's the real expert in that. I can have a conversation with him. He trusts me to do my sensor stuff right. We're having an API between us. It's implicit, it doesn't have an API doc. But I think it's a nice way to look at how we have conversations with our colleagues. Not only fellow devs, but you're also having conversations with people in legal or in marketing. You're making sly, stupid jokes about people in marketing. That's unfair. They have their own expertise that we don't get. But it helps if we can talk to them. So it helps if we're T-shaped. It helps if you're really good at what you know, but also can talk the language, basically have API knowledge about all the other departments in your company or with your customer base. Get to know something about cash flows. Get to know something about marketing. Get to know something about catering. Some of the most rewarding conversations I have in the university are with the people that make my food. Now trust me, once you get to learn their world, you can have conversations about that. And with that in mind, when I was asked to come and speak here, I thought I'm going to push that to the ultimate maximum. Watch me. So I made these. I'm going to put it around, so I have a slightly bigger badge than you. It's nothing to do with ego or whatever, it's just my badge is bigger. And let me turn it on. Takes a few seconds. Power up. Here we go. Blue light in my face. Yeah, I have a. I also have an audio cable. My badge is able to measure the temperature around me. Look, it's now blue, and once I start squeezing this really hard, I have really bad blood in my fingers. I don't know how you call that. So it takes a long time before that LED becomes red or redder. I may need someone that has really warm hands. Oh, mine are really cold. Because that LED switches slowly from completely blue to somewhat purple in my case, and to completely red in some other people's cases. There you go. Yes, different hands that are warm. No, seriously, I don't have enough blood in my hands. Yes, go. There you go. See? Completely red. I'll quickly show it to that side. 1, 2, 3, let go. Because it has a time delay, purplish, and it becomes blue again. Anyway, so what I did, I have a temperature sensor and I have a little microcontroller, and that controls an RGB LED. But I do more. Wait, there's more. There's a little device beneath it, and that sends out my temperature measurement over a 433 megahertz radio link towards that broomstick. Towards the antenna that I glue to that broomstick, towards the device that's over here. And that posts it to the interwebs. Particle cloud, where are we? Console, there you go. Seriously, demos and live effects, here we go. I know. There we go. I wanted to make sure it worked before I showed it. Those are my measurements coming in. And these are raw measurements. Basically, this is batch number 200. And when I start squeezing that, the value that's now 142 will go up a bit. 143, 144, 145. Not enough to make this thing purple. If that man over there would do it, it would go all the way to 160. If I let it go again, it will cool down. So I just did all that. And I'll tell you, I have no idea how all these individual components work. And we go back. Oh, we go back. There we are. Keynote. Yes. This, first component. Temperature sensor. Analog temperature sensor. I looked up the data sheet. It just said that the voltage on the middle pin changes with temperature. I looked at page 2 of the data sheet. It started talking about stuff I could do. Whatever. Works. I had learned, my experience with Leaflet and my experience working with Olivier, I had learned to let go. This works. I get it. So I connected that to this little thing. What I like about this DigiSpark is there's an AT-Tiny in the left upper corner. It's a microcontroller that has 6 kilobytes of programming memory. I have a research project together with the University of Amsterdam and the eScience Center, where the main question is, where do we leave petabytes of climate data? 6 kilobytes of programming memory. Basically, but you can program it, and the nice thing is, and that's why I picked this one, is you can program it really easy by just plugging it into your USB, programming it as if it's an Arduino, taking it out again, works, like a charm. The light effect on there, what I could have done was like have RGB LEDs and then would like manually do the red and green and blue. That's a lot of work. So I didn't want to do that. What I did want to do was use these Neopixels. Neopixels are brilliant because they're digital. And you can daisy chain them. And you can just send digital signals to them that says, you now go on brightness this, red value this, green value that, blue value that. And there's libraries for that. Libraries are APIs. Because they make sure you don't have to write the code yourself. You just trust them, they do what they say they do. And yes, we can talk about certificates later. Neopixels, brilliant. If you get a lot of them and more than 6 kilobytes of programming memory, you can make a skateboard, I did, where the lights match the speed of your wheels, but in reverse, so that the light effect stays stable to the ground. That's what you can do with those. They're really cool. Oh, and I think I made another one as well. We're at the medical conference. Here, Twitter. Yes, I made this one. Here we go. Ta-da! Seriously, this thing measures my heartbeat in my ear and then visualizes it. I brought this to Burning Man. I thought this would be, I was like the geekiest loser ever, of course, but I was proud that I could make this. Also, bringing this to Burning Man also means you take glasses that have USB connectors and wires sticking out of them through customs. Neopixels. I seriously have no idea how they do this, but it apparently works. Where's my cursor? There's my cursor. Here we are. Back to this. Back to this. Here we go. And then finally, the final thing I added to this are, not so fast. Not so fast, clicky. There. The final thing I added to this are those radio controllers. So the left one is a emitter, and all it does, it has a digital pin. If you make it high, it sends a 1. If you make it low, it sends a 0. There's no security whatsoever. Which means you probably have to like decode my measurements into 1s and 0s. And no, you don't. There's a library for that. You don't have to solve that problem yourself. Libraries, APIs, all the same. So that is on here as well. Then the other thing to the right for you of that is the receiver unit that is now here connected to a particle, and the particle uploads it to the internet. Again, an API, because I don't even know the IP address of that thing. That's the beauty of how these things work. Of course, why go to all the length to make like a single one of this just to show you a point? No, We made 200 of these. I think there's 10 here, so if the front row here and there, just take theirs already. I'll turn this one off. All you need to do is open it, get it out of the box, open it, and attach the 9-volt battery. 9-volt batteries have two ways, the right way and the let's fry the electronics way. Yes, let's demo this. Once you turn them on, it takes about 10 seconds. They go in some kind of boot mode, and then after 10 seconds they start measuring. Your LED should go on. If you squeeze the little black, looks like a transistor, is a temperature sensor. The temperature should change. You have hot hands, sir. See, you can see it getting purple already. Once every 10 seconds it will start uploading a measurement. I had mine intentionally on this. They're coming in. So we have numbers 17, 24, 46, 41, 37. You're all doing measurements, they're all coming in. What we're working on really hard is so these measurements are going to be forwarded to a fire server. These will be patient numbers, and the fire server has a calibration in it, so they will be available as temperature measurements. We have 200 of these. We don't have 350 because I know not everybody likes this. But if you do like it, after my talk we have 200 of these, get one. We'll make sure that this central device moves to the devices table for the last couple of days of the conference, so you can play with it. More importantly, if you take it home, we made them in such a way, and you can see that they are not soldered to the PCB. They're connected with headers, which means you can take them out. There's a little goodie bag you get with a breadboard and some wires, so you can make your own circuitry if you want to. But if you just want to work with software, you leave it as it is. I see some really hot hands here. I'm really glad this works. And I think this shows that, I'll show you, good on time, I'm keeping you from beer, so I'll have one more thing to say about the beauty of working with APIs and trusting other people's code. It usually works out. Right? So, officially, my device over here that I can program should be able to interpret your signals and then send them to the internet. And it has a library to do the interpretation, and it has a library to send stuff to the internet. It should be not more than a few lines of code. Then I found out that the library was only written for Arduino, but wasn't ported yet to particle platform because it has a different hardware profile. And then so I started thinking maybe I should contribute, which would be a good thing if I had the time for that, by porting that library. And before I knew it, I was thinking about where the registers are in the hardware on the Spark and the turtles all the way down. And at some point you need to realize maybe it's better to just get both. So, this is my duct tape solution to make this work. The Arduino, you can look over here when we're done. The Arduino uses the Arduino compatible library to receive the radio signal. But then the Arduino isn't online, the particle device next to it is online. So then I just use UART, classic serial communication, between the two to give the measurement from the Arduino to the particle and then upload it. And then I run into something else. The Arduino has 5-volt logic and the particle has 3.3-volt logic. Really? And there's really nice, kind of like the capacitive touch sensor that are in my lab. Really nice, ready-made boards that solve that for you. It's the proper way to do that as an electrical engineer. Sometimes there's a proper way to do things as a dev. Use use that, use this API, then do handshaking, after handshaking, do certificates, and all the proper way. But if you're in a hurry and want to make things work, my solution to that for this problem is always remember that one LED equals a 1.5 volt drop. So if you look really close, there's a blinking LED here that translates the data coming from my Arduino to the 3.3 volt logic level. That's about 10 cents of solution. It only works one way because, anyway, but it works. Don't touch it. So there is some benefit in having that depth, understanding that at some level. And I understand that with these things. I'm at this point in my career proud to say, as a T-shaped person, my depth is in getting these things to work. That's good. I still have no clue what the inside of the AT Tiny looks like. And I have no clue what the server park at Particle looks like that puts all of this online. And I don't want to know. But I want to be able to talk to these people. And I think that is basically what we're doing here for 3 days. You can think that all the hands-on work is getting to know an API, but it's actually talking to people, both through computers and at the beers we're going to have at a few moments. So I really hope you extend the idea of an API beyond bits and bytes and use it in your daily work as well. And I really hope that all of you will take one of these boxes, start measuring your own temperature, and start DDoSing that fire server. Thank you very much for your attention. You'd be pretty good if you can DDoS that using these devices. Let's have a beer. The boxes are in the back. And there's 200 of them, so if you really don't want one, don't take one. But if you do, get one.